No. Let's make a small review of what you have seen last time. So what is this? Yeah, we have seen fixed encoding. We said that fixed encoding is the suitable option whenever the samples are equal probable. Then whenever they are not equal probable, okay, then we have the Hoffman code, which is the variable code. I see that we solve here an example, what to do. Calculate the data, the code rate, calculating the efficiency. Sounds very good. Okay, and then we saw the extended version. Okay, we said that the extended version will increase the efficiency. Yeah, but by the way here, so whenever you do extended, so the first extension, it is guaranteed that will increase the efficiency. The second extension, not necessarily. Then here, this is quantization. Okay, so we did the approximation. We saw here about the number of required bits. Very nice. Quantization levels. Okay, we saw the trade-off. So increasing the number of quantization level, this is good because it will decrease the error. So it will increase the quality. But on the other hand, it will increase the cost because the data rate required will be more. Okay, good. We saw the pixel as an example of the quantization level. We see here that we commented about the properties of the quantization, and we saw the two cases of quantization whenever it is uniform and non-uniform following the PDF as written here. Very good. We commented about the MPEG-4 standard, and we commented here this PCM. Good. So it's good that we made a review. Okay. So here, whenever you have fixed source encoding, if they are equal probable, then this is the suitable option. Whenever they are non-equal probable, then we said this is the variable. There's nothing new. Whatever I added the last time is whenever this one is suitable for equal, whenever the samples are IID. If the samples are non-IID, we need to see something new. Okay, and this something new is the PCM. So, sorry, Amir, later I will not allow. So, this is why I will jump to the new set of slides. Where are the new set of slides? Here. So, let me repeat. Then, whenever the samples are IID, if they are equal probable, then fixed source encoding, right? Whenever they are non-equal probable, variable encoding, right? But whenever they are non-IIDs, we will see that whenever they are non-IID and they are equal probable, we will use something called PCM. And whenever they are non-equal probable, we will see you will use something PCM plus a compressor. Cool. The question now, what is IID? You should know what is IID. But okay, good. Write down this whatever we wrote, then we will continue. Compressor. Yusuf. Amir, I said late arrival is not allowed. Why you enter?
You said later or this session? I don't hear you.
خلص, okay, this session. Next time, don't enter, please. Okay? The same for you, Yusuf. By the way, I have the attendance sheet. Abdul Aziz Talib, who is that? Okay, I know him. Abdullah Fakhro.
Yes.
You are brother of the previous Fakhros or la? Cousin. Very good. They were excellent students. Are you? Inshallah. Abdullah Ayman. Abdullah Khalid. I know him. Okay, good. Ahmad, yes. Ahmad Munzir.
Yes.
Ahsan, I know him. Ali. Ali Naimi. No, Ali Naim. Ali. Not here? Hey, Ali missing. Amir, I saw him. Hamad Khalid, no, I don't know. Where is Hamad? Hamza, I know him. No, this one. Hamza Fawaz. Ah, good. Hani, Hudayfa, Hisham, Hussein, Irzam. Who is this? I don't know him. Who's here? Khalid Suleiman. مين خالد سليمان? Okay, good. Khalid Baraka is the one I know. Muhammad Anwar. Muhammad Hassan, good. ومحمد نور I know him. محمد أبو عسل نصراني. محمد رياضول عبيدة بود عبيدة. وعمر حكم. أسامة not here today, right? أسامة not here. خالد حسين. مين هذا SM خالد? What is the SM standing for? سيد محمد, good. وصلاح وصالح وشهاب. يوسف المالحي. يوسف الشيخ. And I think I missed someone at the beginning. Abdullah Muhammad. Anyone here not on the attendance sheet? Sure. Cool. Good. So, what is IID and what is non-IID? So, IID stands for something that you should know, as I said, independent and identically distributed. I don't care what is the name about. Sometimes I forget myself, but I know what is or what does it refer to. So whenever we have two symbols, well, identically distributed, so they follow the same PDF. Good. So I have the two symbols, X at T1 and the symbol at T2. If they are dependent on each other, we call them dependent. If they are independent, so we call them IID. So now I need an example from you whenever you think about practical systems in life, whenever they are dependent or they are independent. Good. So, Hudayfa. Why you changed it today, the t-shirt? أنت كل يوم فما فريق؟ Okay, good. طيب. Cases of independent يا حذيفة. Sequence of data that the one at time 2 is independent of the one at time 1. For example, a heat sensor. And whenever there is a sensor, they need an electrical engineer. Do you think the reading at the heat sensor, the one that you will have now, depends on the one that you had 1 second ago? Okay. Is it possible that at 1 second ago it was 25 degrees, now 1 second later it is 50 degrees? It depends. So now, if it's now at T1, it is 25. At T2, yes, maybe it is increasing, okay? It will become 26, maybe too fast, 28, but it's impossible that it will jump to 50 in 1 second, right? Then here, the reading at time 2 depends on the reading at time 1. This is the case, the heat sensor, whenever it is non-IID. The function is not non-IID, okay? So here, the source is a non-IID. You have to deal with it as a non-IID. If it is non-IID, this stuff cannot be applied. Clear?
Basically, it was the T2 was 28, then it will be IID because
not here as an example. So here the heat sensor as it is. Okay, you are an engineer. They are giving you this is a factory. Deal with it. Okay, so if you are dealing with a sensor that is a heat sensor and you need to transmit the information from a heat sensor, then you have to do source encoding, quantization, and all of that. You first of all you have to check the property of the sensor. This sensor is non-IID. Therefore, this whatever we have learned here will not be applicable. You have to do something here. It's not because the value of it is of the sensor itself. Understood?
Sorry, if the heat sensor is non-IID,
No. The heat sensor, it is non-IID.
it is always.
non-IID.
So does this mean that always T2 depends on T1?
T2 on a heat sensor always depend on T1. It's impossible that the temperature will make a huge jump. Okay. Other is it clear? So other cases of sensors, localization sensor, exact GPS. So in GPS, okay, you are making a design, okay, and here we have actually a company that makes this, okay, so it's a follow-up. So we have a customer that is moving like this, so moving and so on, moving on the street, right? Okay, they put their sensors on carwas. So is it possible that at T1 you are here, at T2 you are here, at T3 you are here? No, T1, T2, T3. Is it possible? So the sequence has to be sequential. So here, if you are here on the university street, if they are measuring after 1 second, you should be here, close around. Okay, it's impossible that you made a jump and you are here. Okay, then the reading at T2 depends on the reading at T1. This case also non-IID. You have to go here. So here, localization of the GPS, it is a non-IID.
Know it or configure it. For example, if I have jumps,
not because you have jumps, so you have to check your sensor. Okay, so this sensor it is assumed to give me values that are IID or non-IID. You will decide. The same sensor, it might be IID or non-IID. Example, you have any question? I will come later to you. Yes. Heart rate sensor. So the heart rate, okay, good. It is measuring now, for example, 100 beats per second. Good. So after 1 second, it is possible that it is 180.
Depends on the situation. But if this is scary, it will go high.
In 1 second?
No, not in 1 second.
Good. So coming to answer your question. So if I'm measuring the heartbeat each 1 minute, can at T1 here and T2, can they be that different? So for the same sensor, okay, it can be IID or non-IID based on what is the scenario that you are dealing with. And it's only you, the engineer, who will decide that. Okay, so they will give you at Hamad, okay? You know that in Hamad, for every large operation, they need an electrical engineer to be in the operation. يعني مش تزودهاش كثير يعني. Good. So whenever it is a large operation, and you know that in many of the operations now they have a robot. Okay, so this robot, okay, yes, they already give tutorials or classes for the doctors on how to deal with the robot, but there should be someone, okay, who will deal with the robot, okay, and to be monitoring the robot, not the patient. Okay, so the engineer will be monitoring the robot. The supply is okay, no faults, no red alert or whatever. Okay, so that they can still or they can keep using the robot. Okay, especially this robot, if it is a robot that will cut, okay, a bone or whatever, it has to be extremely precise. Okay, so who will decide that? The doctor will say, we need to do this cut. The engineer confirms from the engineer. The engineer will say, yes, the robot is fine. It has been stabilized at this point. You can start the cut. Clear? So they need, okay, an engineer. So coming to this one. So for this sensor, also, whenever there are so many sensors, okay, on the patient. So if this sensor is measuring such a value, okay, some patient will go to the doctor and will see, let's see what is your heart rate. Or imagine there are 2 customers. So we will measure for Ahmad, for Saeed, for Khalid. So the values between them are IID, completely independent. All right. or for the same customer or same patient here, okay, if the time between them is large. How much large, you should know, okay? If, on the other hand, it is for the same patient, okay, and the sensor is on him or her, okay, that measurement is non-IID. And again, this is what is nice about electrical engineering. If they know that it is IID all the time, they will not ask you, or you are not needed. Okay, but because you are there and there is not a clear answer, then you will say, you will check, okay, for this scenario, it is IID, it is non-IID, we can use this, we can use that, and so on.
Systems that use combination logic, non-ID, and the sequential one, the other way around.
Not linked. Okay, so this is why there is no sentence. Well, for this system, it has to be IID. No, you have always to check. Answer? Questions here? No. Voice signal, is it IID or non-IID? IID. Why? Voice signal. I cannot say. Well, say one word. No. Whenever I'm talking, is it IID or non-IID? Now, whenever I'm talking, the information that's here, it is encoded or quantized or sent so that it is recorded and sent to you later on Teams, right? So whenever I'm talking, it is IID or non-IID? Non-IID. Why?
The sequence of the letters, for example. You can't say any letter randomized. So it depends on the letter before.
Very good. Okay, so here, voice signal. In a voice signal, whenever we are talking, okay, let's say English, okay, we're gonna, so here, is it possible that if I say the letter C, the next one will be X? Tell me, give me a letter, a word. C وبعدها X. What? Oh. Come here. Here. Okay, any other word that has C within X? So it's impossible. So then here, what is most probably that will be after the C? YO يعني. يمكن A. Okay, good. So this is why actually the ones who study language, they call them linguistics, okay? They have distinguished between vowels and consonants, right? A, E, O, U, I, right? Others. What are they? بالعربي they are called هذول حروف العلة, right? وهدول what؟
علامات الاحرف.
انت عارف ايش نحكي احنا ولا لا؟
الاحرف
اعرف العلة. What are the others? What's their name? I think that this is the name. حروف ساكنة. Yeah. So the idea is, okay, most probably after this one we will have this one. Okay, this is why after the C there is an O or an A, okay, and so on. So this means that if this is at T1, at T2, the value of what will be or what is expected at T2 depends on what has been at T1. Then here the system is definitely non-IID. Is it clear why it is non-IID?
Yes.
Good. So this is English. Arabic. Same. Okay. Usually all the languages that they have, let's say they are somehow smooth, okay? Arabic is one of the best examples, okay? So the sequence is clear, okay? But do you know about any other language whenever the sequence is not clear? So no. Chinese, so Chinese, for example, it is one word, okay? Another one, and they are not related, okay, in terms of the voice. So it could be IID. طب يعني the phone will become crazy. They will not make a phone only for Qatar, okay, or for Arabic speaker. It's a phone, and it should work worldwide. What will happen with the phone? It will check. Okay, so the phone should be aware of what's happening. Okay, so are the functions or are whatever are related or not related? So do you think that this guy is doing this? No. It should be, but actually it is not. So if it is not, what they will do? Chinese mood? Okay, good. No. Yeah, so whenever they will do it, okay, over any phone, because they don't know where you or who will use them, okay, they currently in the standard, they will go for this option. They assume they are IID, even sometimes they are not IID. So whenever the system is non-IID and you run it as an IID, your system is not optimized. But they will say, this is the only option. This is because they don't know where it will be used, and to make a detector, okay, on the system to detect if it is non-IID or IID after it has been designed, it is challenging. But now they want to do it for 6G. What will be the key point in order to make the phone to decide if it is non-IID or IID?
Doctor, why it matters if the phone knows the word is IID or not?
Okay, good. So whenever we make the design for this strategy, it's different than this one. So if you do it for this one and you apply it on this one, it will not be optimal. So it means that you can still improve the system, but you are not able to. My question now, in 6G, they want that the phone will be able to detect if it is IID or non-IID. What do you think that the phone will need?
You have repeated samples, I think.
Repeated sample? No.
Into the frequency,
Of what?
the voices.
No, even in Arabic, okay? Someone can be with the high frequency, another with low frequency. Female, male. Hassan Sabi, I don't know. So how they will know?
Correlation.
But they need to correlate, okay? So the phone, in order to make this correlation, the phone needs to learn that whatever is using that phone, okay, is using a language, because even some people, they talk two languages, okay? So the phone should be aware that, okay, now this guy is using IID or non-IID. What do you think is the technology that is needed? That's it. Okay, so because in 6G they are going to implement AI in the phone. They have already started with some initial AI approaches. So with the AI approach, because AI needs training, so the phone is trained with your voice. Okay? So it will train itself, the phone, to realize that this function is IID or non-IID. So if it realizes that whenever you talk it is IID, they say, okay, شكله Chinese, okay, then let me apply the best technique for IID signal. If it is non-IID, ولا شكله عربي ولا Italian ولا whatever, okay, then the phone will say, okay, it is more suitable to apply non-IID techniques. And we just said here that if it is non-IID, these are the techniques. If it is IID, these are the techniques. Cool.
Will the improvement be significant?
There will be some improvement that you will notice in terms of quality. So you will hear it with higher quality. We said here, I think last time, that what is the difference between whenever you talk to someone face to face or whenever over the phone in terms of the voice? Some of the frequencies are cut. This is why the special letters B or D or T, you will not realize them alone. Right? Sure. We commented about this? Okay, good. So with that, okay, so if you optimize more the system, you can get more of the quality. So you will feel it much better. Is it possible to cut further the quality? Yeah, so for voice systems, have you realized that some voice systems, they have good quality and others, they have bad quality? Examples?
Android.
No, like if you call on WhatsApp or if you call
Whenever you make a direct call or whenever you call over IP, what's a free app, right? You see the difference? There's a difference. Why? Have you thought about it?
they send less bits.
That's it. So they send less bits. So they made more cut on the signal. So instead of from 100 to 4,000, they will make it from 100 to 3,300. Skype, for example, is making a lot of cuts. Okay, it's known to be cutting a lot from the quality. They will tell you, is it enough? You understand? Yes. And they don't care about the quality. Why for the one that is not IP and Skype, WhatsApp or whatever, they have more quality, they keep the quality? Because you pay. Ooredoo and Vodafone, they want to convince you that if you need quality, whenever you call someone abroad, you have to make a direct phone call so that you will keep the quality. Good. After all, there is nothing for free. Yes, you want more quality, you have to pay for it. Cool? Clear so far? Good. So this was all of this is the motivation why we need to study this stuff, because we already studied this one. Good. So clear so far the motivation? Good. So PCM. This PCM scheme, let me repeat, we said that this is for the non-IID. What else about this PCM? What we call it is a joint source encoder plus quantizer. So PCM will do together the source encoding and the quantization.
What is PCM stand for?
Pulse code modulation. Is it important to know what stands for? No. If you will go to the field, they will tell you PCM. Or you will ask, what is this PCM? They will tell you, I don't know, PCM. Myself, if I have not checked the lecture yesterday, I will not remember. Why? All the people know it, PCM. Good so far? Can we continue? Okay. So let's see now how it works, this PCM. First of all, let's say I will try to follow the same definitions in the book, so that whenever you will study from the book, you will see the same. If you want to study from the book, anyone have you ever checked the book?
Which book are we using?
Sorry.
Which book are we using? Because there are 3 books for communication.
Yeah, I don't know why there is something called syllabus. Okay, good. So we have this interval of the signal. Okay, it goes from, let's say, from -5 to 5. Usually we prefer, okay, signals that are centered over the 0. Okay, so from -3 to 3, -7 to 7, and so on. And if it is not, we recenter it. Okay, so we shift it. Good. So this could be called X max, and this is X min. Good. I put here 8 quantization intervals. Would we prefer 8 quantization intervals? And good. This is also part of the review. Would you prefer 8 quantization intervals or levels, or 9 levels? What is better, 9 or 8? 9? Is a heck. What is the answer?
We prefer 9, yes. More efficient.
We have seen last time that what happens whenever you increase the quantization levels? What? Okay. Whenever we increase the quantization levels, what happens to the error? We have less error. So the quality will increase. Good. On the other hand, we will increase the number of required bits. So the data rate will increase, the required one. So here the cost will increase. Then what is better, 9 or 8?
Depends on what you have.
This is what the answer that I was looking for. Wrong. We said that it depends, right? And this is what we said last lecture. But here between 8 and 9, no, it does not depend. Why it does not depend? This is what I'm going to explain now. Good. So assuming that we are dealing with which one? The first equal probable. So here, so here, PCM equal probable. So if it is equal probable with the 8 levels, how many bits do we need? From quantization, whenever I have 8 levels, no, from source encoding, I have 8 levels, okay, and I want to encode how many bits? 3 bits. With 9 levels, because there is nothing called 3.1, okay, so 4 bits. But with 16 levels, also 4 bits. Log 2 of 16 is 4. So here you made already just jump from 3 bits to 4 bits. You will stay at the 9 levels, or as you already are, you are using the 4 bits. Here you are using the 4 bits, or here you are using the 4 bits. Which one will offer more quality, the 9 levels or the 16 levels? So why to go to the 9? So whenever we go that, yes, we will increase the bit. This is whenever you compare 3 bits to 4 bits. But it is not whenever you compare the 4 bits to the 4 bits. Okay, is it clear, this one? So whenever we go from here to here, yes, the answer is it depends. Because here you are increasing the number of required bits. But whenever you go from this one to this one, no, it does not depend. Simply, this one is bad. Okay, the 16 levels is much better than the 9 levels. Clear this point?
And same cost.
The same cost. So 9 levels, 16 levels, exactly the same cost. Same number of required bits. So if it's same number of required bits, let's go to this one, which offers more quality.
Okay, then that means 9 is better in terms of 8 and 9, right?
Between 8 and 9. So 9, between 8 and 9, there should be no 9. So it should be between 8 and 16, between 16 and 32, and so on. Good? Clear this point? Abdul Ghani. Good? Yusuf, you follow us?
Yes.
Fakhro. Shihab. Good? Abu Asal, why are you so far today? تعال. Move. I want you here. First liner. Amir. All good? The one in front of Amir, your name. Which one of them? Sorry? Ah, yes. Good, يا عبد الله. هاني. شمال أصابعك. You're good? Sure? Okay. So. Okay, good. So we are here. Good. So we have, this is the one. So if I want to calculate number of required bits, we said that if we have 8 levels, we will need how many bits? 3 bits, right? So what we did, the 3 bits, the number of bits equals log 2 the number of levels, m, okay? In the book, it's called m, okay? So b equals log 2 of m. Good? So here, the number of required bits, b equals log 2 of m, and if you would like to put them in terms of m equals 2 to the b. Number of required bits b, or quantization levels, m, and the relation between them is this one. Good? Clear? Hamza, lost? Sure? Now I want to put this one in terms of the whole interval. So here, from here to here. How much is that? How much is the total width? How you will calculate the total width? The total is x max minus x min, right? Fine. If I want to divide it by the number of bits, I like it. This one, so yeah, I will go directly. So here, this one, and in the book, it's called delta, capital delta, like this. So 1 level width, which we call lambda, this is equal to how much? X max minus x min divided by, sorry, the quantization levels, okay, divided by m. Cool. So delta equals now x max or x min. We said that we want them to be 5 to minus 5 or 7 to minus 7. Here we can write that x max equals minus x min. But then here this will be x max plus x max. So 2x max over m. We agree? 2x max over m. طب m 2. Okay, good. So this will be 2x max over 2 to the b. This is x max over 2 to the b minus 1. Yep.
From where did you come with the 2x max?
Okay, it came from here. So the x max minus x min. So let me put it continuous. So this will be x max minus x max over m. This is 2x max. Answer? This was your question? Rayazul. Raising hand? Raising hand? All clear? I saw. Yes.
What if the values are not centered between?
So this is what I said at the beginning. We always prefer them to be centered. But even if they are not centered, we will recenter them. So if you imagine it is between minus 3 and 7, you will say, I will shift it, okay? And I will call it x min dash or x max dash.
So why b minus 1?
Because there was a 2 here, right? So whenever I divide by this 2 to remove it, so it will be 2 to the b minus 1. You know, 2 to the b divided by 2. This is 2 to the b minus 1. Hamza.
Why would you say it's not equal minus x min?
This one? Because I said that we always prefer in practical systems, okay, values that are on a mirror. So from 5 to minus 5, from 7 to minus 7. So they are on the positive and negative. So we account for all options. Good so far? Done? Can we continue? So, also a review from last time. Maximum error. Do you remember how to calculate the maximum error? Let me remind you. What was the example? Yeah, I remember the example. So we said that all the values from 1 to 3, we will quantize them to be 2. All the values from 3 to 5, we will quantize them to be 4. All the values from 5 to 7, quantize to 6, and so on. Do you remember? How much was here the maximum error? How you know it? Yeah, so the maximum distance from 1 to 2, 1. From 2 to 3, 1. Here, also 1. Or here 1, and so on. So how we get this one, if in terms of math?
5 plus 7 over 2.
Which is the total width divided by 2. So here, if this is the total width, how much will be the maximum error?
5. You mean up?
Just a minute. I will repeat. So here, how you obtain the maximum error? You subtract them. 3 minus 1, 2. You divide it by 2. It is 1. Here, from 5 to 4, 5 to 3, 5 minus 3, 2. You divide it by 2. It's equal to 1. 7 minus 5, 2 divided by 2 equal to 1. Good? So maximum error then it is the total width divided by 2. How much we obtained here the total width? Delta. So maximum error. That's it. Delta over 2 min x max. I guess you want to take all of this. But yeah, so far this is the one. Good? Let me repeat. What we call, okay, good, here. This is the interval, okay, or the level from which values 5, yani let's see, whatever is from 1 to 3, for example, following the same example, if it is the numbers, okay? So how much we will approximate the value here, to which value? To quantize it to what? To 2. Good, so how much will be the maximum error from 1 to 2, this is the maximum error, or from 2 to 3, and they have to be the same. So here the maximum error is 1, maximum error is 1. But I want to put it in terms of lambda. So I will say that lambda, how much is lambda, the total width? 3 minus 1, 2. So this delta over 2 is equal to 1, which is the maximum error. Good? Khalid, lost? شكلك lost. Do you want me to repeat? There is another Khalid, right? Where no? 3 or 4 Khalids? Yes, in the world there are so many Khalids, but here in this class we have only 2 Khalids. أشوفهم هذول وين. I have Khalid Abdul Razzaq and Khalid Baraka. SM Khalid, no, his name is SM. صح يا سيدي؟ You said سيدي مولاي ولا no? What's your name? سيد محمد, sorry, سيد. Good يا سيد. You prefer Khalid or سيد? I will call you سيد. Is it okay for you? Okay, good. Sayyid Muhammad. Much better than Khalid. Sayyid Muhammad is family name? Sure? أخلص زي خالد. SM Mu'in, yes. I know. But it should be the first one is the name, right? Not the family name.
لا دكتور في دول بالعكس.
ما هذوك Chinese usually. Right? So in China, yes, they put the family name first. Okay, good. Chinese influence. Good so far? Questions?
Delta مش التوتال ويدث الانترفال. هي التوتال ولا لا؟
Here total width of each one of the levels. So here delta is only from here to here, or from here to here, or from here to here. The total is not the total one. The total one is x max minus x min. So this you see whenever we calculate this delta, it was x max minus x min over the total number of levels. That was your question? Clear?
Okay, this example like a hereditary table, so it should be 1 to 2, right? Not 1 to 3.
I said this is an example now here. No, not because here it is 10 the total and you divide it in 8, so each one is 1.25. So it's completely not wala 1 wala 2.
For the example, for the maximum error, the number of bits was 1, yeah? Because 2 power 1 would be 2. The quantization level. If 2 minus 3 over 2 and 5 minus 5, 4 minus 5 over 2.
What?
3 minus 1 over 2. Why always divided by 2?
Why I always divide by 2? So I take the whole length, which is from here to here, and divide by 2, because whenever I divide by 2, this is the allowed, this is the maximum error, which is this one. Clear? So the maximum error is always this total length divided by 2, because this could be the error here, or could be the error here. This was your question? To answer, no?
Can I take the whole interval as 1 delta, like from minus 5 to 5?
You can, yeah, you can. I cannot tell you, you can call it or delta or W as you want. So, but yeah, as long as you know how much is calculate the maximum error, that's fine. Good so far? Raising hand. Your name? Abdullah, right? Yeah.
The full range from minus 25 to different ones, not the 8 samples we have.
There is a way, okay? So he can divide by the 8 and divide by 2. But I think this is what he was asking for. تقريبا شكله لا زين. Good. Clear? Okay, good. So this is the value of the maximum error. What else we can obtain for this setup? Notice that we are taking the whole period. So here it is from the 5 to the minus 5, and we are together making intervals, so we are doing quantization, okay, and at the same time we are linking to bits, so we are doing source encoding. This is why at the beginning I said that we will jointly do the source encoding and the quantization. Whenever we will move forward, you will see it more, okay? But so far, you should be aware now that we are dealing with bits, okay, and with intervals. So this is why we are doing all together. Good? Okay, so coming back to our story. So this is the maximum error. But I want to get the average error. How much is the average error? No. Okay, let's see. We said that from 1 to 3, all of these are quantized to 2, as an example, right? So the value of 1.175, it is quantized to 2. How much is the error? 0.825. The value of 1011, it is quantized to 2. How much is the error? 0.989. The value of 2.2 quantized to 2. How much is the error? 0.2. And so on. How to calculate the average error? We have to add every one of the values, okay, and divide by them. So how many values we could have? No, fish depends on. How many? Infinity. So here we could have an infinite number of values. Then you have to add all of these infinite number of values. Whenever you add infinite number of values, what does that look like? Can we add infinite number of values? What is the operation that is an addition of infinite number of values? Integration. So, okay, so here, then in order to calculate the average error, and I'm sure you have seen this in so many courses before, it is the integration from minus infinity to infinity of the value multiplied by what? Let me remind you. And the best example is whenever you calculate your GPA. Okay, whenever you calculate your GPA, do you add the grades for the labs and the courses all together and you make the average? What you do? You take in account that that is 1 credit hour and the course 3 credit hours. So you do a weighted sum, right? So here you should, whenever you make the addition, you need to know what is the probability for this, 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 and so on, right? What will measure all the probabilities here? I'm asking. But first of all, are you convinced that I need the probability of each one? What? I will come later to you. Okay, so are you convinced that in order to make this average, I need to do the average, okay? That we need the probability for each one of them? We cannot add like that, right? Right. What measures the probability for each one of them? Guys, I always assume that the electrical engineers are the best in what, يا خالد? 3 Khalid, right? واحد منهم يجاوب. Math, physics, programming, signal and system course, probability and statistics, life, business, money. What? Fortnite. Okay, good. Yeah, so what is this, guys? What? That's it. So here, this is called the PDF. The probability density function. What is the probability density function? It is telling us what is the probability of each one of them. This is why it is always, okay, whenever you want to calculate the average error, you do x f x dx. No? You don't remember? خلاص نرجعك على كورس probability. يعني it will not work, okay? This course is heavily based on probability and signal system. ليش طبعا اديتها بالعافيه؟
اخر معها سيركت وفيزيكس 2 ونيوميريكال.
يعني what do you expect in electrical engineering? let me stop the recording. Where to stop the recording? Here. في mute. Yeah, stop recording. But yeah, where the complaining will go? Okay, good. Right, good. Conclusion. I assume you are excellent in math. Okay, this assumption it has to be there. So then here, whenever I deal with the average error, this is the way. I need the probability density, the PDF, the probability density function. Good. How to obtain this PDF? Here we said that they are equal probable. If they are equal probable, then how much is the error? What do you think that is the distribution for the error? No. Kinds of PDFs that you have seen. What is the one that it is equal for all? Uniform. Okay, so the one it is here we said it is equal probable. So the PDF that is for equal probable is the uniform, right? Whenever we will study next lecture the non-uniform, we will see another kind of PDFs. Okay, but now we will see the uniform PDF. What is the property of this PDF? If it was continuous function, it will be like this. Okay. So this one, it is the PDF of the error. What is the value here? From where to where? What is the maximum and minimum error? It is well written on the slide. Maximum. It is in blue. So here, this PDF, it will move from what is the maximum value to the minimum value. So we said here the maximum value is lambda over 2. The minimum it will be minus lambda over 2. Good. This PDF, do you remember what was the integration over the whole PDF? 1. Good. So here, then this rectangle area should be equal to 1. If it is equal to 1, how much is the amplitude here? And for that, Mr. Hamza Fawaz, bueno. Where is Omar? Omar, amplitude. How much is the amplitude? Yes, I want you to obtain it. How much is it?
2.
Yeah, based on what 2? Yeah, let's see. Wala 1. Okay, so here. You are engineers, guys, or future engineers, inshallah. Rectangle. Area of the rectangle equals 1, we said, right? 7th grade school. Area of rectangle equals what? Length by width. Mumtaz. Good. Okay, good. How much is the length here? Distance from here to here, it is equal to delta. Multiplied by this amplitude, which is here the question mark, equal to 1. Then the question mark equals to how much? Alhamdulillah. So here the value is 1 over delta. Good. PDF characterized. So whenever for the PDF, you should know what is the PDF that matches your system or setup, and then you should know where it is moving from to amplitude and so on. I'm sure you have seen this in probability and statistics. بالعافية مش بالعافية مرتوها. You should know. Good. Sorry. PDF. I don't know. Impulse function. I don't have no idea what you're talking about. Maybe something else. We have to put this in the integration. Good. Clear so far? Fakhra, lost? You are lost?
دلتا اوفر 2 ماينس دلتا اوفر 2 يطلع دلتا.
Delta over 2 minus delta over 2. This is equal to delta over 2 minus with the minus plus delta over 2. This is equal to delta plus delta over 2. This is equal to 2 delta over 2. This is equal to delta. More stuff? Sure. Questions? Anyone lost? Let me, I can repeat, it's fine. Sure. Khaled. Clear? Yusuf, you follow us? The other Yusuf. Yusuf, you follow us? Good. So now we have to put here into the integration, we will obtain the average error. Okay. Last time, questions? Last time, whenever we saw the quantization, we commented about a metric to know how good or bad is the quantization. Do you remember what was that metric? Yeah, Hudayfa, no. Hamza? No, I want the name of the metric. No. To know if the quantization is good or bad. Batarani, what was the name of the metric? We saw last time something called SQNR. Do you remember? You don't remember? Well, I have not explained it. I will check. Mahalla, I will check, huh? Maybe. Who knows? I said maybe. This is why I'm checking. Wallah, you are right. Bonus, صح? Good. So, metric. So here, what is the SQNR? This is a metric to know if quantization is good or bad. What it stands for? SQNR, it is called the signal to quantization noise ratio. You have seen the SNR in previous courses. Do you remember it? What is the SNR? Signal to noise ratio. Okay, so the SQNR is equal to here signal power over quantization error or noise power. What is the unit? What was the unit of the SNR? It's a ratio, so it is unitless. Okay, it is power over power. Watts over watts, nothing. Okay, so here it's the same. The SQNR, it is unitless. Okay, because it is signal power to the quantization noise power. So every system that has quantization, in order to know whether it is good quantization or bad quantization, it is inducing a lot of error or what, they will go and they have the SQNR. Good. Again, it is a signal power over the quantization noise power. Good. So, and for our system, if you would like to calculate, then we need the quantization noise power. Good. So here, I need to calculate the quantization noise power or quantization error. How to do it? First of all, how to calculate the power? Integration over x squared. Good. So this then it will be quantization error by the PDF. In the book, they put X hat, okay? But yeah, we can call it whatever you want. So now here, I want to integrate, so it will be X squared, the PDF. You obtain the PDF? Yeah, I can write it here. So the PDF, where I can write it? Here, the PDF is equal to 1 over lambda, but it's only from minus lambda over 2 to lambda over 2, 0 else. So if I would like to put it now here, it will be from minus lambda or delta over 2 to delta and here 1 over delta dx. I'm right? Yeah. This is equal to the 1 over delta will go out. This is equal to, anyone lost so far? I'm just doing the math, okay? This is x3 over 3 from delta over 2 minus delta over 2. 1 over delta of delta to the third over 8 over 3 minus I think it's okay. If I made a mistake, let me know. So this is delta over 3 over 24 plus delta over 3 over 24. This is delta over 3 over 12. 1 over delta, so this is delta square over 12. It's correct. Let me check. Maybe I have it here in some place. Hussein, what are you doing? What are you checking with the calculator?
Double checking if it was confused with the 1 over. Well, isn't it supposed to be 2 over 8 and then divided by 3?
2 over 8. It is this value, so it is x3 to the, so we're inside the x, we'll put delta over 2 to the third. So here it will be delta to the third to 2 to the third. 2 to the third is the one that is 8. Do you want me to repeat? Do you want me to repeat? Do you want me to repeat? Is it clear for all? Razul, lost? Sure? Anyone wants me to repeat? Okay, good. Once we have this here, this delta, whose phone is ringing? Yusuf, turn off and leave, please. So, then here the SQNR equal the signal power over the quantization power, which is delta square over 12. This is equal to 12, the signal power, over delta. How much is delta? We obtained delta before, right? Here you see it was x max over 2 to the b minus 1. So here, over x max over 2 to the b minus 1 all squared. This is equal to 12, the signal power, over x max square over 2 to the 2b minus 2. This is equal to, I will take this one, I will put it up. So 12 multiplying 2 to the 2b minus 2 multiplying to the signal power over x max square. Sorry?
We have to calculate the signal power.
كنا حلوين. كان يا مكان. Okay, good.
You need to do that in one definition or just calculate the noise power equal to
I don't know. Definitely, I'm against memorizing. مت ايش؟ انا ما بحبش الانتجريشن. ما ايش؟ Okay, good. So, but I don't want anyone to memorize this one and say, okay, this is the equation. So this is why I will make any changes. Okay, good. So This SQ and R, do we want the value of the SQ and R to be large or small by definition? Where is the SQ and R? Here, this is the SQ and R. It's the signal power over the quantization noise power. We need the quantization noise power to be large or small. This is the error, so we want it to be small. Ideally, how much?
Zero.
Ideally 0. It's impossible to be 0, but ideally 0. If it is 0, how much will be the SQ and R? Infinity. So then the higher the number of the SQ and R, it will be the better for us. Do you agree? The higher means that this one is the lowest possible. So always the SQ and R, we want it to be the highest possible so that we say that our approach is good. To increase this SQ and R, looking to the equation, what you can do to increase the value of the SQ and R? Increase the signal power or decrease the what? Decrease the X max or increasing the B. I will stop here. Next time you will see how to do each one of them, okay, and what is the implication for each one of them. The quiz is up to here. How many questions in the quiz? Allahu a'lam. I have not written it yet. But why is that important? You study more or less? Okay, good. I will decide. If it is a lengthy quiz, I will tell you to leave after the quiz. If it is a short quiz, you will stay. أربعاء أحسن. Do you want to change? لا خلاص. The quiz is up to here. I have drawn the line. You still have until Wednesday to let me know. So Wednesday, after tomorrow, I will ask you again when do you want it to be, okay? We stop here and see you on Wednesday, inshallah.
بس عشان الاس كيو ان ار